This is a video presentation of Chapter 7, Section 2, Parallel and Perpendicular Lines. We'll start off with the definitions here. Parallel lines are lines in a plane that never meet. Lines in a plane that never meet. Perpendicular lines are lines that intersect at 90-degree angles. Lines that intersect at 90-degree angles. And then we have a transversal. A transversal is a line that intersects two or more lines that lie in the same plane. A line that intersects two or more lines that lie in the same plane. Now the reason we spend time studying parallel and perpendicular lines is because parallel and perpendicular lines create all sorts of different and interesting angles that we need to study in relation to the geometry of the 8th grade. So what we're going to really be looking at here, even though parallel and perpendicular lines is the name of the section, we're really going to spend time looking at the angles that those create and not really spending so much time on the lines per se. So with that said, let's go ahead and start looking at those angles created by those lines in example number 1. Question number 1 says to measure the angles formed by the transversal and the parallel lines, and then they're asking us which angles seem to be congruent. So this would be a time at which it would be prudent to start doing some measuring, since that's what they're asking for here. So I'm going to get out my giant protractor here and try and measure some angles. Well, let's start with the angle marked 1, because that's what they're asking about. Remember, the way we do this here is we line up this point here in my protractor with the vertex of the angles, and this flat part of my protractor here lines up with one of the lines that I'm trying to measure. So since I'm talking about angle 1, which is composed of these two lines, I can either line it up with the line that shoots off to the left or the line that shoots off to the right. It doesn't really matter. And then what I do is, whichever line I don't pick to line that up with, I read off to see where that angle measures out to. And when I read off here to the left, right, we can see that that measures 150 degrees. So that angle is 150 degrees. And as I go around and measure 3 and 5 and 7, you're going to see that all of those actually have that exact same measure. So there must be some type of relationship there for all of those to have the same measure, which is where they're going to take us here in example number 2. Now as I go measure angle 2 here, right, again, I can choose how I want to line this up. I'm going to line it up so that the side that kind of runs to the left here, a little bit more westerly here, matches up with the flat part, and then I'm going to read this off to the line here, and that matches up with 30 degrees. So that angle is 30 degrees. And when I go through and measure 4 and 6 and 8, well, those all measure 30 degrees as well. So there must be some type of relationship among those angles as well. And again, that's what example 2 is going to have us look at. So instead of speculating, let's go take a look at example 2 and figure out what that relationship is. So what they're telling us here in the directions for question 2 is that line L is parallel to line M. So these are my parallel lines, and we're supposed to find the measure of each angle. So just to go back and talk about a vocab word really quickly, this line that cuts across those two parallel lines, line L and line M, those are called, that's called rather a transversal. Right? That's all a transversal is simply a line that cuts across other lines. In this case, it's cutting across two parallel lines.